Scientists are investigating the effect of disease on a number of sheep in a small island. They discovered that every year the death rate of the sheep is greater than the birth rate of the sheep. Of course, it means that if the death rate is greater than the birth rate, that means there is going to be a population declination. The difference every year between the death rate and the birth rate for the population on the sheep on the island is 3%. The number of sheep on the island is P at the time T years after the scientists had begun their investigations. Write down a differential equations that relates P, which is the number of sheep on the island, and time. Okay, so that's what we're going to do. Death rate, that means it's talking about the rate of the increase of the population. So we can just call it dp death dt. Okay, so what does it mean? The death rate of the population of the sheep. Okay, that's why dp death means population of dying. Okay, rate, so we divide it with respect to time, is greater than, okay, this is bigger than the birth rate, dp birth dt. Okay, so now the difference every year between the death rate and the birth rate is 3%. So let's convert that into a mathematical statement. So if we take the death rate minus a birth rate, right, the difference is 3%. So 3% means 3 out of 100 of the population, which is P, right? So 3 out of 100, 3% of the population. So now d birth dt minus d death dt is equals to, okay, minus 3p over 100. Now why is that so? If I were to convert the birth minus death, it's going to become a negative number, right? So, or you can multiply throughout the expression by minus 1 so as to bring the birth minus death. Okay, so that's why it's negative 3p over 100. So that's the relationship, differential equation relating the p and the t. So what is birth minus death rate? Of course, that must be the population rate, right? dp/dt of the population of the sheep. Okay, so birth minus death will actually give us the rate of increase of the population. But of course, in this case, since it is declining, so that's why we have a negative 3p over 100. So there we have a differential equation relating p and t. So solve this differential equation to find an expression for p, that means the population, in terms of the time. Okay, so let me just bring the p across to this side, so it becomes 1 over p, and I am going to cross multiply the dt over to the right hand side, so it becomes negative 3 over 100, which is basically 0.03 times dt. Now we have separated them according to the variables. So I have got p with respect to p on the left, and the constant which we can integrate with respect to time on the right side. So let's now start integrating now. So if I take 1 over p and if I integrate it with respect to p, this is of the form f prime x over fx, right? So because p, if I differentiate it, it should be a 1, right? So 1 over p is going to become ln p. So ln p is equals to, this is simply a constant integrated with respect to time. So we're just going to put a t after the negative 0.03. So it will become negative 0.03 t plus a constant of integration. We will just add a plus c. Now therefore your p, if you want to make p the subject, so ln means log to base e. So I'm going to just bring the e across to the right hand side, and this is going to become the power. So it will be e to the power of negative 0.03 t plus c. Now of course e to the power of c is also a constant, so I can split it up like this: e to the power of c times e to the power of negative 0.03 t. Okay, so e to the power of c okay, is a constant, so I can replace this e to the power of c with just a single constant, okay, denoted by an alphabet a. So I can just call this as a e to the power of negative 0.03t. So we have solved the differential equation, okay, for p as a function of time t here, okay. Now the next part of the question is asking, explain what happens to the number of shapes if this situation continues over many years. So when we say many years, we are referring to the time frame when the time tends to infinity, when the time becomes very big. So as t tends to infinity, your e to the power of negative 0.03t, what would it tend to? Of course, it's going to become very small, okay. The reason is y equals to 0.03 times an infinity is going to become infinity, and e to the power of negative infinity is the same as 1 over e to the power of infinity, and that is going to become 1 divided by an infinity, and of course that's going to become extremely a small number, that's going to be almost 0. So what will happen to the population if this situation continues? If I take this part, is going to become 0 and multiply by any constant that you have, which is a, and this is of course going to become 0. If this is equals to 0, what will happen to the population? Of course the population will ultimately become 0 as well. So over many years, if you don't do anything about it, the population of the sheep is going to become 0, or it's going to become extinct. If the situation continues over a time, there would be no more sheep left in the island. So that will be the answer for part 2. Now what happens now is that the scientists are investigating the disease, investigating the effect of a disease on a number of sheep on a small island. They discover that every year the birth rate is greater than, the death rate is greater than the birth rate. Still, the difference in the every year is also the same 3% as we read earlier. But this time what has happened is the number of sheep on the island is p at a time t years after the scientists began observation. But here is the difference, okay. The scientists import sheep at a constant uniform rate of n sheep per year. That means every year they're going to bring in n sheep. The difference every year, okay, between the death rate and the birth rate still continues to remain at 3%. This time we are supposed to write down another differential equation to model this new situation. As we know from the first part of the differential equation, we had dp dt is equals to negative 0.03p, right, because it's a 3% decline every year. So the rate of decrease of the population is going to be 3%. So now the scientists are importing sheep at a uniform rate of n sheep per year. They're going to keep adding p sheep per year. So that's why you have to add a n, because though it is declining at this rate, we are going to keep adding n sheep every year. So your new dp dt is going to be negative 0.03p plus n. And now we need to solve this differential equation to find an expression for p in terms of t and n. So for this we're going to just do variable separable. So I'm just going to bring the negative 0.03p plus n to the left side, and I'm going to integrate it with respect to p, and I'm just going to cross multiply the dt to the right hand side. So it is just going to be dt or 1 dt. So I can just put in a 1, okay. So I have just brought it up here and brought this entire expression down here as a reciprocal. So now we can integrate both sides with respect to p. So let's put the integral. If I want to integrate this, so unless if it is of the form f prime x over fx, that type of form, then it's easy to integrate it straight. So if I were to differentiate the denominator, okay, negative 0.03p plus n is of course a constant. When you differentiate, it's going to become 0, so we can ignore that. But however, when we differentiate negative 0.03p, so we should have a negative 0.03p in the numerator. So what I'm going to do is, outside I'm going to put a 1 over, okay, negative 1 over 0.03, so that on the numerator, okay, inside the integral sign, I can introduce a negative 0.03. So you can see negative 0.03, if you can cancel with the negative 0.03, it's the same as this step. So with respect to p, now it is very nicely integrable. And on the right hand side, 1 if I integrate with respect to t, 1 if I integrate it, it's simply going to become a t plus d. Now on this side we have got negative 1 over 0.03, right? And I could just cross multiply this number over to the right hand side. So it's a negative sign. So when I bring it over, it's going to become negative t. And of course 0.03, which is a division here, if I bring it to the other side, it's going to become multiplication. And d is a constant. When I multiply that by 0.03, it's also going to be a constant. So instead of writing 0.03d, I just changed it to a e, okay, which is another constant. Now we can see this is f prime p over fp type. So when I integrate it, it's going to be ln of whatever that is in the denominator, which is n minus 0.03p. That's what I have written here. And then the right hand side has already been integrated. So it is negative 0.03t plus e. Now from the ln form, we are going to change it into exponential form. So ln means base e. So n minus 0.03p is going to become e to the power of this whole thing, which is on the right hand side, which is e to the power of negative 0.03t plus e. So we need to make p the subject, right? Because the question says find an expression for p. So what I am going to do now is, okay, if I go to the right hand side, if I were to split it up as two different numbers, so I can write it as e to the power of negative 0.03t times e to the power of e, rule of indices. So the e to the power of e, okay, the capital E is what I'm going to call it as an alphabet b, okay, which represents a number. So b e to the power of negative 0.03t. This b means e to the power of capital E here, okay. So now let's throw this across and make p the subject. So 0.03p, if I throw this to the right hand side, it's going to become negative 0.03p is going to become positive 0.03p. And of course I would throw this to the left. So what I'm going to have is n minus this thing. So it's n minus b e to the power of negative 0.03t. And of course, as you can see, the next step is we just need to divide everything by 0.03. Just leave p alone on the left. So p is therefore equals to, okay, 100 over 3, because 0.03 is 3 over 100. 3 over 100, if I bring it to the other side, it's going to become 100 over 3 times n minus b e to the power of 0.03t. So that is going to be the population expressed in terms of time. Given that the number of sheep settled down to 500 after many years, we are supposed to find the value of n, okay, that means how many sheep were introduced per year, right, so that the number of sheep settled down to 500. So here we are going to change the p to 500. So as t tends to infinity, right, your p tends to 500, okay. So e to the power of, what happened to the e to the power of minus 0.03t? So it's going to be equal to 0, right, because if you substitute infinity, so you're going to get negative infinity, e to the power of negative infinity, of course, which is going to become extremely a small number, which is going to be almost 0. And then if you multiply 0 by any number, it's still going to be 0. So b e to the power of negative 0.03t is also going to be equal to 0. From n, I am going to subtract a small number, okay, which is almost 0. So the p is simply going to become 100 over 3, okay, times the n, okay. So that is what the population is going to become. And this population is what they say settle down to 500, okay. So given p tends to 500, okay, it's going to be almost equals to 500. So in other words, 100n over 3 is going to be almost equal to 500. So when it does so, what will be the value of n? So n should be 3 times 500, which is going to be equal to 1500, and which you divide by 10, it's going to become 15. In other words, the scientists have to keep importing 15 sheep per year, and if they do that, okay, after long time, the population of the sheep will sell down at 500 sheep.